we've finished with the microscope now. What we'll go and do now is look at the grain size distribution of the sand using these sieves. As you'll see, we have the largest mesh size in the very top, and gradually we go down smaller and smaller mesh sizes until we get right to the bottom, and this is where the very smallest grains pass through every mesh and end up in the pan at the bottom. Now, how are we going to use these? Well, down on the beach we describe sand as well sorted and as poorly sorted. Now, these sieves allow us to quantify exactly how poorly sorted or well sorted the sands are. So I'm going to put them back together now, and we'll sieve the sands and we'll look at the results later. And all we do is shake gently for 5 minutes. Okay, so let's have a look and see what's in each of these sieves. There's a couple of grains in the largest one, quite a few more in there, a lot in that one, a good swag in there, fair amount in there, smallish amount there, just a tiny amount there, and just a few grains in the pan. Immediately we get a clear visual impression of the amount of sand in each sieve. We can take the sand in each sieve and weigh it to obtain its mass, and from that mass we can construct a histogram which gives us a very clear impression of the degree of sorting of this sand. The horizontal axis shows the grain size, largest on the left and smallest on the right. The vertical axis shows the mass of sand in percent. The mass of sand in each sieve is represented by a column. The histogram for this beach sand shows that almost all the grains have been captured by just 3 sieves. Okay, so you've seen the histogram, and from this we can construct a cumulative frequency curve. Sounds a bit complicated, but in fact it's very straightforward to construct. Here's how we do it. The vertical and the horizontal axes are the same as the histogram. The tricky bit is that we want to plot the total percentage of sand that fails to get beyond a given sieve size. But in fact, this is quite easily done by simply moving the columns successively to the right on top of each other. The top of each column is marked by a point. And then we draw a smooth curve through all the points to give us our cumulative frequency curve for the beach sand. Okay, you've seen the histogram and the cumulative frequency curve for the beach sand we collected. Let's now look at the histogram and the cumulative frequency curve for the desert sand. With this desert sand, nearly all the sand grains have been collected in just one sieve. This gives a very much steeper cumulative frequency curve. And here's the beach sand curve for comparison.